In this video, we'll look at another way to solve a quadratic equation, and that is using the process of completing the square. Let me give you this equation. Consider x squared plus 6x plus 9 is equal to 3. If we tried to solve this by factoring, we would first have to subtract 3 from each side to get x squared plus 6x plus 6 is equal to 0. But this equation does not factor since there are no factors of 6 whose sum is 6. So we can't use factoring to solve this. But let's go back to this original form of the equation. X squared plus 6x plus 9 on the left side actually does factor in a special way. When we look at x squared plus 6x plus 9, notice that this is factored as x and x, and then the factors of 9 whose sum is 6. Well, that happens to be 3 and 3. In other words, we can write x squared plus 6x plus 9 as x plus 3 times x plus 3, which is also x plus 3 squared equals 3. And then hopefully this looks like the property that we applied in the last lesson, the square root property, which states that x plus 3 is equal to plus or minus the square root of 3. So x is equal to negative 3 plus or minus the square root of 3. So we have an equation that was not factorable when we put it in standard form, but we can write it in a special form that enables us to apply the square root property. And this special form only works if one side of a quadratic equation is a perfect square trinomial. So if the left side of the equation can be written as a perfect square trinomial, we can write it in factored form as some binomial squared equals a number, and then use the square root property to solve it. So before we go further in this process, let's talk about perfect square trinomials and how we can recognize them and what the relationship is of the numbers inside those perfect square trinomials. So we have this expression x minus 4 squared is a binomial squared, and when we square that, we actually get a perfect square trinomial. If we square this, remember that this is x minus 4 times x minus 4, and we can FOIL it, but we would get x squared minus 4x is minus 8x, and then plus 16. Another example is y plus 2 quantity squared, so when we multiply that out, y plus 2 times y plus 2 is y squared plus outer and inner are each 2y plus 2y, which is plus 4y plus 4. And then a minus 7 squared is a minus 7 times a minus 7. Multiplying that out gives us a squared minus 7a is minus 14a plus 49. And so the x squared minus 8x plus 16, y squared plus 4y plus 4, a squared minus 14a plus 49, these are all perfect square trinomials. And what I want you to observe is how does the constant term relate to the coefficient of the variable in the middle, that is the linear term. So how does 16 relate to negative 8? How does 4 relate to 4? And how does 49 relate to negative 14? Well, would you observe that 16 is 4 squared, right? But 4 comes from half of 8. In fact, it's really the same thing as half of negative 8 all squared. the 4 and the 4, well, 4 is the same thing as 2 squared, but that's really half of 4 squared. 49 is 7 squared, but that's the same thing as half of negative 14 squared. So it turns out that in a perfect square trinomial, the constant term is always going to be half of the coefficient of x squared. And we're going to use that fact because what we're going to have to do is create a perfect square trinomial to use this completing the square process. So the steps to solve with this third method is we will first write the equation in standard form, ax squared plus bx plus c equals 0, where a is equal to 1. If a is not equal to 1, we have to divide each side of the equation by a. Because let me point out in this previous slide that this relationship between the constant term and the linear coefficient only holds when the coefficient of the square term is 1. So we have to make sure that our coefficient of the square term in this type of process is 1. So if it's not 1, we divide everything through by that value. Then we're going to take the constant of the equation to the other side, and we're going to complete the square of the binomial on the left. So our goal is we're going to have two terms involving x squared and some number x equals some number on the right-hand side. So we've got to figure out what number is going to make the left side a perfect square trinomial. And that process is called completing the square. And then we'll be able to factor, because this perfect square trinomial will factor as some binomial squared equals a number. And then we will apply the square root property and then solve the resulting equation. So let me demonstrate this for you. And honestly, this method is really good to use if you have a coefficient of 1 on the square term and an even coefficient of x. Otherwise, I would say you don't have to use completing the square because you can introduce a lot of fractions and it can be quite tedious. And the next method, called the quadratic formula, is actually based on completing the square, and it will give you a formula that you can use. So completing the square is great, and it's needed in some instances, but just know that there's kind of limited times when I would actually prefer it over the other methods. We have x squared plus 12x minus 4 equals 0. Observing right away that this does not factor because there are no factors of negative 4 whose sum is 12. So I couldn't even do factoring if I wanted to. To use completing the square, I want to get the x squared plus 12x on one side, and then is equal to 4. And now I want to find the number that's going to complete the square. So recall that in a perfect square trinomial, the constant is always the coefficient of x divided by 2 squared. So we will take half of 12 and square it. So half of 12 is 6, squared is 36. And we're going to add that number to each side of the equation because the big rule of equation solving is what I would do to one side I have to do to the other to keep it balanced. And now x squared plus 12x plus 36 factors. If you need to write this intermediate step, you can, but it's x and x. The factors of 36 whose sum is 12 are 6 and 6. In fact, the number inside this binomial will always be the number that you just squared to input the 36. And then on the right, 4 plus 36 is 40. So we have x plus 6 squared equals 40. By the square root property, we get that x plus 6 is equal to plus or minus the square root of 40. And solving for x, we can subtract 6 to get negative 6 plus or minus the square root of 40. But we typically write the radical in simplest form. There is a perfect square factor of 4 times 10 and the square root of 4 is 2 on the square root of 10. So the two solutions are negative 6 minus 2 on the square root of 10 and negative 6 plus 2 on the square root of 10. And you could use your calculator to find the decimal approximations of those numbers as well. Part B is 3x squared plus 30x plus 54 equals 0. Notice the equation is in standard form, however the coefficient of x squared is 3, not 1. We first divide each of the terms by 3 to get x squared plus 10x plus 3 into 54 is 18 is equal to 0. Now we want to get the x squared plus 10x on a side by itself. We subtract 18 from each side to move the constant over. And now we find what number completes the square. So I have to take half of 10 and square it. Half of 10 is 5, squared is 25. I'm going to add that to each side. X squared plus 10x plus 25 factors as x plus 5 times x plus 5, or x plus 5 squared. Negative 18 plus 25 is 7. By this square root property, we get that x plus 5 is equal to plus or minus the square root of 7, and subtract 5 from each side to get negative 5 plus or minus the square root of 7. So the two solutions are negative 5 minus the square root of 7 and negative 5 plus the square root of 7. Now completing the square can be used on an equation that factors, but it can also give us solutions that are irrational solutions, like these two examples. It can also be used to find the imaginary solutions, because if you have a negative number on the right-hand side after you complete the square, which is possible, the square root of a negative number would be an imaginary number. So you can get all types of solutions by this process. But again, the dividing by the coefficient of x squared is only necessary with this particular method, completing the square, because I have to have a 1 for the relationship with the constant in the middle term to hold true.